Okay.
Okay.
Hey, this is Coffee Compiler Club, and anything to do with compilers and language runtimes and garbage collection and pattern matching in languages and anything else to do with language implementations are all fair game. You're being recorded live, hopefully up on YouTube within an hour or a day. And then for people here, I'm going to J-Crete next week, so I don't think I'll be on. If I can, I'll let people know, but the flight timing is such it's unlikely I will be running even remotely. So we're going to skip next week. That's the current plan. That's it. So no agenda per se. Cameron said he's just been talking about doing pattern matching, so I think that's a great opener. Oh, and people are still pouring in now. Fine. Cameron, you want to?
Sure. Yeah, I mean, not full bore pattern matching in terms of, I mean, I've seen some pretty crazy stuff out there, but basically type matching in a switch. So with a full ISA.
You got a syntax you can throw in, like the obvious questions are shit like you do subclassing matching, you do exact versus inexact matching, you could mix nil or not with subclassing.
Yeah, so basically the general, I'm just pasting it in here.
Should I make it live here? Why don't I do that?
Yeah, sure. You know, it's a typical switch statement, like, you know, so it's all tuple based, so you can have any number of things you're switching on, and you know, you can have multiple you know, those are, you know, tuple 1, 2, 3, whatever.
Right, but now show that's the
right. So then we wanted to add basically an ISA test to it, so that one of those could be, so for example, we might want to say, you know, switch some value of X, Y, and Z, where what we want to say with the Y one is that, you know, that it's a ISA test, right? So we might, I don't know, I'll make up a syntax here, like in case one, something, and, you know, hello, right? And for the something, you know, if this is an ISA test, basically, how do you say that? Because let's say you're testing for a string type, that would be an exact match of Y to string.
right, but you're doing Java number, which includes integer and double.
Right. So what we ended up doing for syntax is we said, so we have the .is pseudo function, if you will, pseudo method, if you will.
So it's not in the case, it's in the switch expression.
Yeah. So basically we say, hey, in this case, what I'm wanting to test for is not Y equals string, but I want to test that Y is string. And that allows us to have, you know, any number of those within the sorry.
So like, so what I'm seeing here is syntactic sugar to break down a tuple.
It's actually not syntactic sugar, and well, with a tuple I need to actually parentheses, I guess. No, it's not syntactic sugar. It's this is a valid expression that would just always give you a compiler error because the type is
underscore is not defined or something.
Right. It's what we call the black hole.
Yeah.
So for example, with a lambda, you know, so it's primarily used for things like lambda, where I say, hey, give me, you're going to pass me something I really don't care because I'm going to assert, right? Something like
a wild card.
It's I think it is called wildcard by some languages. Yeah.
That's it. It's just an
underscore.
It's an unused lambda variable argument to a function.
So we call it either black hole or ignore, depending on the context.
Yeah. Okay.
So the is testing for any type. You can.
Yeah, that's the equivalent of the Java instance of.
If you want to test it for integer on the next case, it's fine. There is no problem.
So you could say, you know, case, you know, to, you know,
integer.
Yeah,
whatever. And there's another case where you can use, so in a case,
Yeah.
you can say match any, right?
right. And you also don't get a variable for it then.
Or we don't get a variable for any of them. So it's
Okay.
not a binding variable in this. So that's the thing I was saying. It's not.
Well, can you use Y as a string in the right of case one?
Yes, of course.
Okay,
You know, foo takes a string y.
yeah,
In
Yeah,
this case, bar takes int, right?
yeah, but
I
Z,
can
I
say
guess Z is
bar.
available and not bound to anything in particular. Like in case one, Z is known to be the constant string hello.
Yeah, these are R values.
Hmm.
X, Y, and Z are R values, right? So
These
I have
are some
int
values
X
defined.
equals dot dot dot.
Yeah,
Some object Y.
Y,
equals
yeah,
dot, dot,
right,
dot, and some string Z equals dot dot dot, right?
right,
It's, for example.
yeah.
And
But-
of course the you know.
But
can
isn't
also-
R values just like irrelevant? It's an L value in this use case. Why is it R value?
they're being used, the compiler requires them to be an R value, meaning you switch on a value. And normally when you say value, you mean it's implicit
Well,
that it's R value.
So you are
L
Y
value
is
is-
R value,
is-
so you can cast a single thing. But if you had an arbitrary computation for what you have for X, so instead of saying X there, you said X plus 7.
Right, that works. That's an R
Right.
value. X plus 7 is an R value.
X plus 7 is an R value?
Yes,
Oh, I'm sorry, R value. No, I had L value.
you got
I'm
left,
getting
right mixed up.
senile. My apologies.
So,
Okay, fine.
you know, we went through a bunch of, yeah, exactly. So we went through a bunch of different syntaxes. And the reason we didn't do the one that's shown there with the, as a case with the is because that would allow each case to have a different test. By putting it up in the switch portion, it says that there's a uniform
Mhm.
test operation. It just applies to different cases.
Yes.
So, but I'm not saying that's wrong to do. It's just not the decision we were making. So our switch statement is generally, you know, the goal with a switch statement is generally you do want to be able to optimize to an offset jump, you know, if
Yeah.
possible.
And if you can get, I want to say closure, no, completion.
Right. We do track totality as well. Yeah.
Yeah, which you can get if you have the pattern once up front and demand everyone uses that pattern. But if
And
you
we
have
also-
arbitrary expressions through the middle, it's difficult.
Right. We also have what we call a switch ladder, which is it's basically just a different syntax for an if-else tree, right? So you can say switch with no thing, and then basically each case has to be basically an if statement. So you'd say case X is less than Y,
Oh, any arbitrary if
or
expression,
case, exactly,
and
case
it's just an if else
Z
tree.
is
Yeah,
you know, is a string, whatever.
string, yeah. Right,
But,
case, blah, blah,
It
blah.
turns out we thought that would get used a lot, and we're actually considering dropping it. We only have a half a dozen cases in our own, half a dozen instances of the switch ladder in actual code. So we're not sure if the complexity outweighs we're not sure if its usefulness.
Right, you
qualifies.
added a language feature and no one's using it, so maybe. You can do
Right.
that. Any of those ladders get big?
No, that's the funny thing. Every single one in our code has case, default. Every single
Right.
one of them. Case, default. So basically it's a quaternary, not a ternary.
Case default, yeah, it's if thing else,
Right.
and that's barely worth doing something. What's your default syntax on the first case, the middle
we would-
one?
We just say default,
Okay,
this.
yeah.
So we could
that's
say
all.
default, which is actually the same as saying case,
Well, you have to exclude 1 through 10, a wildcard, yes, wildcards around.
so this would actually be a compiler error because you have two the default and the case underscore 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 are the same.
Yeah,
So it'd give you an error, but either one of those works.
yeah.
Yeah.
Okay.
Yeah. So, yeah.
So,
Anyway.
yeah, mostly you put the is a test in the switch, which forced every case to have a
A
class that you're is owning.
Type in this case.
Yeah, type. Yeah. Yeah.
What
And then
about the,
obviously for the X's, you have integers, and then for Z, which
Is a string.
because you don't put an is on the Z there. What do you do with like, can you have Z also show up in a case with like a 17 instead of a hello? Like
No,
suppose
because it's a string.
is object Z.
So if we said object Z instead,
Yeah, say object Z there. Now, can you use the string quote hello quote? It's a object.
you can, but it's not compared as a string. It's compared as an object because we compare based on the compile time type, not based on the not based on the V table.
So reference equality, not string equality.
Object is actually reference equality. Yes.
Yeah.
Because there is nothing else at that level.
Because there's nothing else. Yeah.
Exactly.
Okay. So if the string's in turns are good, and if it's not maybe what you're expecting.
so what about class?
Well, actually, so sorry. When I say reference equality, I don't mean pointer equality, although it often is the same as pointer equality. So all strings that are HELLO are reference equal, even though they are not the same pointer.
Okay. So somewhere you take a step to say that strings have a reference equality test that involves inspecting the contents of the string.
Here, I'll share my screen if you let me. So I can
Yeah, you have to wait a second while I sort it out here. All right, try now.
okay, give me just a second. So I'll share screen. I'm going to do advanced. I'm going to choose a portion of my screen because I have a big screen. All right, how's that?
Yeah.
Good enough?
Yeah.
We'll look up objects. So object in XTC is an interface. It implements comparable. Notice this is an interface, but it's what we call a funky interface. So that's a static, that's a function, not a method. So this is not a virtual, equals is not a virtual call. So what it means is that object is claiming it knows how to compare two things. In fact, let's take a look at the implementation. Here's the implementation of that function. It would be a compile time error for this not to be here because it says it implements a funky interface. Therefore, it has to have the functions from the funky interface. And what you see is it does compare the reference of one object with the reference of another object. Now that reference is itself, is itself an object, and that object is called ref. So when you get the reference for an object, you get another object. Turtles the whole way down. And that reference has an identity as a property. So we will take that identity, let's see, sorry, reference
I'm missing where identity went.
Here's identity. This is what an identity is. So an identity is a hashable, or hashable is, sorry.
Yeah, I mean, I can guess hashable.
Hashable's hash code and equals. So going back to identity, it takes the identity's hash code and it compares the equality of the two identities. So, so when I ask if two refs are equal, they are equal if and only if they have the same identity. So two strings with the same characters happen to be defined as having the same identity, like two ints, 4 equals.
Somebody took a string somebody took a wad of characters and declared it a string, and at that time they inspected the string and they had to somehow declare it equal to some other kinds of strings in the world that also have the same set of characters. There's a character by character inspection being made, and I'm trying to decide if it's being made at the time.
So that's string equals, which is totally different than identity.
No, you just said I'm doing 2 strings and I'm using the object equals on them.
Right. Well, it's a little more complicated than that, because it's not limited to string. It's any const.
I'm picking strings because I have a clue as to what it means, not because
But
I
string
understand
is
it's not limited to strings.
string is a const, like an int, and the identity of a const is equal across 2 objects, even if they're at different locations in memory, if they're, for sake of terminology, bit patterns are the same.
Yeah, okay. So somebody's doing a bit pattern comparison on these 2 strings in order to implement object equals.
Right. If the pointer is different, then it would check that stuff. Exactly.
Okay, so somewhere in their core guts of the universe, when I do our 2 objects equals, you'll stop and say, and now compare the bits that the pointers point to and see if they're bit by bit identical.
Yes, exactly. If there are 2 different locations in memory for a const, we would compare the struct. Exactly.
Yeah, okay, fine. So I'm morally opposed to that one, but that's fine.
Well, that's how, for us, that's how 4 equals 4.
Yeah, I get it for 4, but not for string.
Understood.
Yep, okay, fine.
So what it does is it hides whether or not we intern it or not, right? Like, so it becomes a choice of the runtime how to optimize for that. So we just push everything onto the runtime and assume it'll magically optimize everything.
Well, there's a couple choices being made there. That one of them is, as a user, there are times when I don't care to do the interning step, and there are times when I absolutely care to intern, and when I don't have the option to turn it on or off. Here's what it sounds like. Where did I picked up? Oh, Dan showed up.
Well, it's not that you have the option to turn it on or off. It's that
Well, that is the point.
No, what I'm saying is that what it does is it eliminates the difference between it says 2 immutable values are the same if they are the same bits. I mean, that's 2 immutable values of the same class are the same if they have the same bits.
It doesn't matter if they're point to different locations, they're the same.
Yeah.
Right. And so that way we don't have to worry about the location. So it means that we could intern if we choose to, we could not intern if we choose not to, or we could do a bit of both and it'll still work correctly.
Right. Okay. So I have 2 different things here. The choose to intern or not has a performance impact in an interesting set of cases.
Right.
But basically, I have been down the path of diagnosing and debugging other people's bad Java performance where they use strings everywhere. And the answer was they failed to intern. They had billions of copies of strings they're using for small dense integer like behaviors, but they didn't intern them, so they just blew out their memory. It was just horrific.
And we have a planned situation where, at some point the things are not interned, and then we compress their heap to write it out to disk because we want to page their app out of memory.
Well, you're too late already is what I'm saying.
No, my point is when we page it back in, they will be interned.
And I'm saying is if you touch the disk, you lost. You don't have to touch the disk if you interned up front because you got a 1,000,000-fold reduction in size.
Oh yeah. I mean, that's an alternative. What I'm saying is that one of the goals for our design is to be able to take a running application and move it out of memory without skipping a beat, move it back in and continue.
All right, so the other thing is, I'm sure you have an answer for this one, though. This one hopefully is easy. I just want to have a fucking sentinel. I want to have a sentinel in the land of Java. I make a sentinel by saying new object.
Right.
It's a unique pointer. It never exists anywhere else. I have several of them floating around. They're all different sentinels. I test them some way that says, are you this sentinel? And he says yes or no, even though there's a plain old object. What's the equivalent in XTC?
Yeah, you can do the same thing. The syntax is slightly different because object is not a class. So you'd say new object, open, close, parentheses, open, close, curly. And
Okay,
that's
and that
just
would
called
give me a
gensim.
thing which has no contents, would be bitwise identical to all other things that I make that are like it. But it
right,
would
but it's
still
not.
test
But it's not a
different.
it's not an immutable value, so it would test differently. Yeah,
It's not immutable, even though it has no fields.
correct.
Why not? Why is it
Because
not
it-
immutable?
Because it's a class, not a const. When you knew an object, so we have here. I'll share again.
Yeah.
Portion of screen. So let's go back to object for a second. I had that open somewhere. You'll notice the object's pretty minimal. So it has equals defined by the comparable interface. It has toString, which is kind of handy in a debugger. And it has make immutable. So when you call make immutable on something, it returns an immutable of itself, right? And it does so by freezing the underlying structure and casting itself as a result.
Does make immutable give
so-
you a new immutable version, or does it mutate the thing into immutability?
It mutates the thing into immutability.
So how do you check this at runtime when these objects are immutable?
How would you test if something's immutable? You just
Well,
I
say
have one already floating around the system. It's known to be mutable.
Yeah.
Suddenly another thread makes it immutable.
and so this is most commonly implied by what we call a const. So an enum, for example, is a const, a module is a const, a package is a const, int is a const. So these are all consts. And what happens is by the time a const finishes construction, it is immutable. So before there is a this, it becomes immutable.
So am I allowed to declare something immutable willy-nilly whenever I want?
At runtime or at compile time?
You can also say, instead of saying const whatever, you can say class whatever. And this, you know, for a circular list that you want to make immutable, how do you do it? Well, you make it a class. The node has to be a class because otherwise you can't. The age-old problem, if something's immutable, you can't make a circular list out of it, right?
Right.
So in the case of a node, here, let me just.
Yeah, right. I understand that right. The question I have is, are you wedging yourself into a corner where you have to have a runtime test to test that you're immutable or not? Because I had a mutable version, I mutated it. I make it immutable, but I've already escaped the mutable version into the universe. Somebody's off busy thinking they have a mutable version and doing mutation things to it.
So
Yeah,
anytime that you're dealing, the assumption is anytime you're dealing with a type that has both mutable and immutable instances, that there's an optimization that you just can't do. Anytime you're dealing with a const, like an int or a string or whatever, you already know it's going to be immutable. So the compiler can make that assumption that it is immutable because it will always be true.
Right, but if I have a mutable thing that I make immutable at a future date,
Yep.
It-
Then
there
that
exist people who have-
optimization is impossible then.
You constantly have to check.
it's not an optimization, I would say. It's I have to do a test at runtime.
Yeah. But what I'm saying is that test can be elided if the type is known to always be immutable.
Okay.
Yeah, I mean, there's no shortcut.
Well, that was the question, was you know for a fact there's no shortcut. So this turns into, what is the cost model for how I deal with things, especially if I have to build something complicated that's cyclic, and therefore it's going to be mutable for a while and then immutable thereafter. And is there something going on there? Like I do this all the time right now with my types in AA. I intern them, including cyclic things. They're cyclic, they have to be mutable. Once I get past my interning step, make immutable. I have to treat them as immutable, no compiler support, but they're treated as immutable in terms of the runtime performance.
Yes, let's take a look at make immutable. I think
You have a lot of
Yeah.
make immutables.
Yeah,
which
sure.
totally makes
A lot of
sense.
code. So this goes back to Aaron's question earlier, right? Like, I have a list, I want to make it immutable, but someone else is holding the mutable copy, right? So we don't generally just call make immutable willy-nilly on stuff, because that destroys, your object graph, right? Because immutability is deep, so whatever you point to, whatever it points to, so on, you call make immutable, you freeze the whole graph.
Yes.
So in this case, this is what we call freezing. So a list freezer is something that is a list of an element that's what we call shareable.
Yeah, don't go too deep here.
Shareable is either immutable or freezable, basically. And then, so this is mixed into a list that's also a copyable collection, because we're going to copy the list to freeze it, possibly. And the list freezer itself makes the list freezable. So this mix-in, when you add this mix-in to a list, the list becomes freezable as well. So basically, it first tests to make sure that everything's either already frozen or services are unfreezable. And if it is, it just says, okay, return an immutable copy of me. Sorry, everything I am is already immutable, so just freeze me.
So at runtime, this has to go somewhere in the object header a bit. Is it mutable or immutable?
Exactly.
Yeah.
So for any object that could be either mutable or immutable, it's probably a vtable replacement, but it could also be a bit in the header.
Bit test, okay.
Yeah.
Okay.
And then if it's not an in place, then it has to go through and actually freeze the items in the list.
And that's done by actually copying things? I can't read the code enough.
So basically it asks each element if it requires a freeze. And if it does, it replaces the thing with the frozen version of it.
So one interesting question would be, because if it's a list, because it contains another object of a list, if you call freeze on the head, does the head freeze, or it freezes the whole list, or it freezes the whole chain of
So if
objects?
it's a linked list,
Mhm.
and you call freeze on a node, it'll freeze the entire
List.
Yeah.
linked list of nodes. Yes,
The entire structure, not only the
that's
object.
correct. That's correct.
So essentially, I heard you said I made a defensive copy.
Right. That's normally what we would do, is make defensive copies.
Okay, so what I get back out of this is the copy, and the prior mutable list still runs around the universe.
That's right.
Okay, which is fine. I'm just like trying to clarify in my own head. Like now there's two
It
versions.
can
of
be
it.
just collected, the
Somebody's still
mutable.
hacking away on it. I have an immutable
Right.
version over here.
Yeah, and we can also, like, you'll notice when you call freeze, you can say, hey, I want you to freeze in place. So you pass in place is true. And basically it says don't copy the list, change the list to immutable.
But what if what would happen if some code already depends on the list being immutable, for example, and somebody calls freeze
Being mutable, you mean? Yeah, then it breaks. The
Immutable.
code breaks. Exactly.
At runtime.
at runtime?
At
What
runtime, yeah.
exception? What exception would rise?
You get, give me a second, because I
No.
can't remember off the top of my head.
Of course.
No, it's not module. It's
You're trying to mutate, like,
so there is an exception. It's not deadlock. It's not timeout. It's read only. You get it says throw new read only.
Okay.
Mhm. Okay. Object has made.
so I have like a producer-consumer pile of work, and some interrupty like thing is adding things on, so he's changing the linked list head constantly. And then somebody says, I'm gonna take the whole chunk as it stands right now off to the side and work it.
Right. And remember that we have a lot more optimizations available, because we do not have any concurrent mutable state.
Hmm.
Other than explicit atomic properties, which are a single piece of state. That is, I could swap out the value in an atomic property.
Right. But you don't otherwise have concurrent things. So you're expecting the single threaded flow of execution to understand that he has or has not got mutable or immutable or anything like that. Yeah, okay, interesting.
Mhm.
Let's see. Yeah, so that's it.
Yeah, I mean,
Okay.
I'm staring at, I haven't stared at in a while. I've been staring at doing basically final stores as a way to freeze something. But, you know, to do a freezer list, you have to walk the list and do your final stores as you go.
Mhm.
It has a similar set of issues. I'm not
So-
expecting to make a defensive copy as part of the standard libraries. I'm just going to freeze it in place. But the
Yeah.
typing system, for me, at least in theory, says I won't let you freeze if you already have a mutable version floating around, or I'll give you the type error beforehand. You won't get a runtime error. That's
So
my
it's kind of a single ownership concept, but applied to immutability safety. Yeah, I mean, there are
Yeah.
different ways to slice the cat.
Yeah.
In this case, like we have a very tightly controlled runtime model around concurrency and mutability.
Yeah.
So we get to take a different route, and it's not attempting to save every possible bit and every possible clock cycle. So it's erring on the side of it's erring more on the side of usability, understandability, and
Did you ever look at
And-
Pony?
I did early on, 5 or 6 years ago. I did, yeah.
Yeah, okay. Yeah, it's worth a visit, but maybe you did that already. They do deep freeze operations, but they have a semantic hard theoretic proof that they got it all kind of thing, and then they know that it's frozen.
Another use case I can think of is an object construction. You have an object with the multiple fields, and the object is mutable at the beginning. You populate it and you freeze it, and from that point,
Right.
the object is immutable.
Right, and that's basically what we do with a const, except we allocate the structure for the object. That's what the constructor works against, is the structure.
Mhm.
And then before the object itself is wrapped around the structure, even though I'm pretending, because there's no
Yeah, yeah.
separate object in reality. It's just a
Mhm.
slight difference in the pointer. But in the when you have the structure, it's mutable inside the constructor, and then you return from the constructor,
It's-
and something happens to create the actual this for the object.
Mhm.
Obviously, it's a no-op, but at that point, the structure is no longer mutable.
that
So you have
would
a line
say-
in the sand where you declare the whole structure immutable.
That's right. Exactly.
You can define zones in which you know that the object will be populated, and you just make it mutable to all the way. And when you know the object is constructed, you make it immutable to save the
And it
another
actually
creating.
created one of the weirdest things in our syntax, which is a finally on a constructor, because it's necessary sometimes to do something after construction. But if you're inside the constructor, you return before the thing is made immutable, and then you don't get another shot at it. So we actually have a clause, a finally clause on the constructor itself that fires after the construction completes. And as you can imagine, since constructors are all a nested mechanism, for each thing that you've gone through in that hierarchy, there has to be a particular, very predictable order that those finally clauses have to execute in as well. So
So the finally clause runs after the thing's made immutable. What is
that's correct. That is
part of-
correct. But before the this is returned to the new.
So it has to have implicit order. That's what.
Yes, exactly.
What do you do on the thing that is already immutable that you cared to return this?
I could find some examples, but generally speaking, there are things that you can't do until you have a this, and you'd like to do in the constructor, but you can't because there is no this yet.
Yeah.
So basically it says, okay, here's your this. So you generally you're calling some method, on the this.
Pointer, but you want it done at the constructor time. Like in the lane of Java, you usually do I want to say nested constructors, and the innermost one fills everything in, and then you have the next outer constructor calls this constructor with this keyword in a constructor, followed by, more stuff. And it's a virtual call usually to go register the object somewhere else, but you didn't want to register. You wanted to always register in the constructor, but you wanted it registered only after it was final fields were final.
Right.
I want to return to the pattern matching. Does it deal with object hierarchies and ADTs and interfaces and classes? Can you match on that?
You said
Can you
is.
switch? The
Right.
is a type test. I'm specifically asking for a ADTs and interface and a hierarchy behind it.
So I'm still not picking up on the question. So it's basically the equivalent of testing on instance of in, say, Java. So yes, it tests for interfaces, it tests for subclassing. It's the
And for the exhaustivity, if you, I don't know if you can mark something on exhaustive of something like a seal class hierarchy. So interface.
So in theory, yes, we haven't implemented that yet, but in theory, because we close over the type system, we would know if it's exhaustive or not.
Mhm.
We just haven't implemented the exhaustivity check yet.
Do you have something equivalent to generics?
Absolutely.
Yeah. Okay. And can you
We
test
have,
those?
we have reified generics. Yes, exactly. So it's the is a test. It's the same as a test. So it's basically the assignability test, if you will.
Yeah, right. Unfortunately, Java cheats on that one, and then expects the runtime tests come because they do erasure.
Yes.
And you don't actually erasure, right? You keep the types all the way.
That's correct.
You have runtime type information.
Absolutely. Yeah. Perfect runtime type information with no erasure.
Yeah. I mean, Java, a different VM under the hood could have done that.
Yes. So Josh, when he wrote the generics, there was no erasure. And then the VM stuff that he needed for that wasn't done in time. So they told him we need erasure. So he had to rewrite it in a hurry.
Yeah.
So,
yeah, that's not an easy hack for the VM, that's for sure.
Right. But he, at least the way he told me, he said that he didn't want to do erasure. He was forced to because of the schedule on the release
I totally
of the
believe
VM.
Yeah. That's an ugly thing if you didn't bring it in from the start.
Yeah, they had a JDK schedule release that was separate from the JVM. So Java was unhooked from the JVM in terms of release trains, is my understanding.
Okay. Next.
Anyway, so that was pattern matching, if you will, pattern matching light.
But you didn't matter. Well, you didn't talk about
We don't do variable binding and pattern matching or anything like that, but we don't really need to. That's the thing I never quite understood. I'm guessing it has to do more with the runtime model of the languages that need that, is that it's too expensive to access something from a pattern matched, so they have to bind it to a variable. Like I just don't get it.
So in the land of Java, you bind. No, okay, that's right. So in Elm and shit, there's no name for a thing. You did an expression that had no names. Here, I'll pull up let me bring up the Google Docs and go share, yada yada.
Cool.
In the land of Java, you did it for because they didn't want to override the names. But let me do I want to say an Elm thing, but I think this shows in other languages. So somebody says I have an expression and I want to switch on it. And then here they said case maybe foo or just. That's another one. Just a foo arrow, and then you do foo like things, and case nothing arrow, whatever your default is. Okay, so what do you do with the just with a breakdown is a tag enum, and he pulls out a thing out of an option. Okay, so E0 computes an option, but there was no name ever given to the part that was just in a thing. So this name is new, never before seen, so I can't reuse a prior name. I have to have a name here. I put a name somewhere. So E0 is just, in this case, just, you know, tagged as a type, and then it has parts within it that I know are available to me. I could do this similar behavior if I say persons are known to have names and employers.
Right.
And they have a name and have an age and have a sex or whatever. And there's the boss person who has a name and he has a list of people, you know,
Right.
roles and whatever, right?
That's the binding I'm talking about. Exactly.
Yeah, right. So here I'm E0 is an arbitrary expression that computes something ridiculous. I don't know how he got there, but it came up with one of my tag enums. Because it's E0 is a complicated expression, I don't have a name pre-given for person.name or person.age. So I can't put that name inside the switch. Like you said XYZ, because those names pre-existed.
Right.
But then I said, hey, what about X plus 7, comma, Y concatenated with ABC and, you know, whatever Z is. Okay, Z I can use directly. But the result of X plus 7, I don't have a name for.
Well, you could just give it a name there in the switch.
I didn't in the expression. So here, if instead I go to this, go to a tuple here, and this is the sum tuple, and this is the stir tuple, and this is, I don't need a name here because I have Z directly. Now I can use sum over here to mean whatever X plus 7 turned into. What I heard you saying is that, no, I should come over here and say sum is equal to, and have a name for it. Or break it out and stuff up here, say int sum is equal to X plus 7, and now I can use sum here.
So we would just do this right here,
Yes, right. You put a name in the expression, which is all I can do in AA. But if I'm in other languages, I can't typically make a new name in the middle and then use it somewhere down below.
It's a pain in the ass to compile that, but it sure is handy being able to scope a name to an if or a switch or a for or a while.
Yeah. Person, you know, somehow I got a person somewhere in the world, and then I'm back around to having person name. I never had a name for this person. And I'm going to do something over here, you know, where I'm going to say, if sex, so age is less than 18.
Right. And so what we'd say is like
insurance, you know, plus, whatever, your cost goes up on your insurance. Okay, fine. So what I'm really trying to say here is, so in order to get name or age broken out, if I just said a person P is equal to get me a person,
right,
I still didn't get the name broken out yet. But then I would say, oh, I have a person P, and I would say P.age. But I can say, person has 27 fields in it. I only want the age field. So I'm going to ignore all the rest and pull out just the age field.
Right.
This has to introduce a new variable and bind it in the scope of field, and also has to account for alpha renaming. It doesn't need to name the variables as you name them in the definition of the class.
Right.
That also has to be resolved.
Well, this would have to be named as the same as I put them in the class. So somewhere up ahead, I said person P.age is equal to 18. I actually read it.
But alpha renaming should the name shouldn't matter. That's what alpha renaming states. You can name it anything you want, and the compiler should figure out what it stands for.
Right here, I took a shortcut, and I said, I know I want a person. I'm going to break out the fields. I have to name the fields I'm breaking out a person.
Yeah, naming.
27 fields only want name and age.
Yeah, I understand. I hear you. You can, in Scala, for example, you can rename whatever you wanted. The compiler will alpha rename because the name doesn't.
Come along here and replace the word age with some funny name where some funny name is meant to be age as a rename. How does he know that I'm talking about the age field?
That is alpha renaming.
But how does he know I'm talking about the age field here? I don't see the word age anywhere. If there's an age field, I want some funny name to refer to the age field. How does
How
he
the com-
bind some funny name to the age field?
It will look at the constructor, the
Yeah, and the
person.
constructor doesn't say some funny name, and it has 27 fields, not 3. I'm only showing 3 here, but he has 27.
They're from left to right. In the constructor from left to right. If let's put more context here. Let's say if you have a class person,
Yeah.
that in the primary, because
As soon as you said left to right,
Same
you gave me
thing.
the answer.
age.
Straight,
int.
yeah, age is an int. Well, wait, fine.
So
Yeah, and Java is actually defining now deconstructors to be able to do this in the same.
Well,
type of
that's what
thing
I'm
in Java.
pointing out. Here is a deconstructor and another language Elm that takes a subset of fields that you're interested in and just gives you a shortcut name for them.
mhm.
You don't have to say person P. Right. So here you've done a constructor syntax, but I said I have 27. You're only showing 3.
From left to right, it will. And if you don't want the rest, you can do this one.
Yeah, but no, I want the 17th. Show me how to get at the 17th one.
Oh, I don't know if we would be able to.
Exactly. Well, this is what Elm will do. It'll let me get up the 17th guy
Right, just by name.
just by name.
Okay,
But I have to
okay,
match the
you can.
So I am a little curious though.
If you want.
Why is sex Boolean? Because I'd hate to be the guy with false. That would be.
I didn't. So very funny. So I have a story here, right? So here I am doing this big data company. We're taking these data sets from all over. Sex shows up as a column in every fucking person data set on the planet. Everyone has male, female, and missing. All these have a missing thing. Okay, turns out in like a huge count of data sets, a huge count of the time, if somebody asks for your sex and you're women, you refuse to answer. And if you're a man, you put male. So the data set will be 50% male, 40% missing, 10% women across a large variety of data sets. So, you have to do it and you have to do the right thing. But as soon as you hand it to data scientists, they look at it, scratch their head once and say, missing is female.
Okay, you can abstract it in
So
another
1% will
class.
be, questioning by modal, by gender, whatever. I don't know, whatever name they want in the moment. They didn't want to identify left or right, so they put missing. They left it a blank. But that's 1%, statistically insignificant. So no one cares in terms of the science or the,
Right.
who you're targeting with or however you're doing your math there.
So
sex
the
has 3, male, female, and missing.
Okay.
And draw your conclusion from there.
So for the answer here, if you want to write the 17th to rename it, you have to wildcard the 16 before them.
Yeah,
and if
16 commas and 16 wildcards. Right, right.
Yeah.
And that's what I'm just saying. That there is another version of the world here which does breakdown on the fields inside person that lets me shortcut just a handful of fields that I'm curious about.
So Cameron, can you put guards in some of the cases? Case if x greater than 10, for example.
So just with the switch ladder, which lets you put any Boolean expression in, but no. So the switch itself, even though it supports ranges and wildcards, it does not support greater than or less than or anything like that.
So one other subtlety is if you match on the case, can you introduce unrelated cases, unrelated with the variables? Can you do that? Can you introduce a case that doesn't use a variable or does something completely different? For example, Scala can do this. You can introduce unrelated cases or variables.
Example. So his example says, XYZ is a 1 string hello, 2 through 10 int bar. Okay. And then there's a default case. So you go up 2 blocks of code in the doc. Yeah. And then there's another case you want to add in here, which is completely unrelated somehow. Yeah. Doesn't use XYZ.
Yeah.
Yeah. Nothing like that.
Yeah, I would say no to that too.
So it's only related on the variables you use.
No,
on the values.
On the values.
On the values of the tuple specified in the switch itself.
Yeah. I think the mindset here is that each case is exclusive. They're not tested in order. They are each mutually exclusive.
So they are theoretically tested in order because, for example, on this first case, I could say 3, which falls inside the 2.10. So So I could pluck out, so theoretically, because range doesn't give you an error. Now, if I have two that are exact, I get an error, but
Yeah.
range is forgiving on the compiler error side.
But I would claim that you're internally rewriting this to saying 2, 4 through 10.
We're not actually. We actually compile it as a
series of
sequence of tuple constants. Yeah.
Okay. But you want at runtime, then you have to test them in order, because if you test 2 through 10 first, you'll screw
So
up.
we actually have a number of different algorithms that the runtime chooses from based on the data.
Right.
And the reason it has to be done at runtime is because there are a few things that are true compile time constants, like pi. Pi is a compile time constant. But there are also things that we consider to be runtime constant that are not compile time constant. So we can prove at compile time that it's a constant. It's going to be a constant. We just don't know what its value is.
But you can't just plug that in.
And so at runtime, theoretically, we could have two cases that have the same exact value. If at least one of them is a runtime constant, theoretically, it could end up with the same value as another case. So there is, if that happens, then we have to evaluate in order. And the algorithm has to behave as if it evaluated in
Right.
order.
No, semantically, evaluate in order. I understand there's, you turn the optimizer loose on it, but semantically, it's as if you evaluate it in order. That's interesting.
Yeah, and this is one of the things, by the way, that always, this is one of my few gripes about Java, is that everything has to actually be a compile time type, meaning the value, compile time constant, meaning the value has to be, the actual value in the case label has to be visible exactly that value to the compiler.
Yeah. I mean, I do switches.
That bit me 1,000 times because I can build anything out of switch statements. So
Right. I would have done switches with things that are static final const things, except it's not allowed.
Right.
Yeah.
Anyway, it's a minor detail, but it always stuck in my craw, so to speak.
Right.
But
I would like to claim that I would like switches that were known to be or semantically treated as if they are all, each case was mutually exclusive of each other.
We do try to prove that, but that one slight difference between a compile time constant, meaning we call it a compile time constant if we know the value at compile time, versus a runtime constant, which is one that at compile time we prove is going to be a constant value. We just don't know what it is yet.
But you can't then claim that the switches are all mutually exclusive. That's
correct.
And therefore order matters. And that's the thing I would like to know when I'm writing a switch, that my belief at the time I write switches is that things are all mutually exclusive.
Yep.
And I'd like the compiler to tell me they're mutually exclusive.
I'd like to argue that it was a pragmatic decision. But again, if you're going for absolutely predictable, number of clocks spent on this instruction, then the choice we made is not a good one.
This isn't for the clock speed. This is for semantically understanding at a glance. These are all mutually exclusive. That's my goal for that one, not performance.
So as I understand it, it's the switch is implementing some kind of flow sensitive typing, because you don't need the cast the Y if you test it here.
Yeah, we do flow sensitive typing everywhere. It's I hope to never go back to a language that doesn't have it.
Yeah.
So,
right. I'm certainly flow sensitive typing in AA.
Yeah.
So we almost never have to cast. Almost never. Basically, the only places we cast are like in writing serialization code type thing,
Well, and if you fail such a cast, you have to throw an error then, right?
It does, yes.
Yeah.
In fact, we don't call it a cast, we call it a type assertion.
Yes, that's a good answer.
So if here, let's say, if you don't need the values and Y, you can make this an interface some kind. So you can test for interface.
Yeah, you would just put the name of the interface there.
Yeah. Right. Yeah. Skip the y.is. You just put the interface there.
Mhm.
Yeah.
Oh, okay.
He already has the why that is
Okay.
at the lead of the expression. So get rid of is, you just put an interface. No, don't put an underscore y, get just the
Okay.
interface.
Okay. Okay.
Yeah, there you go. Right. And then because, types are always capitalized according to fiat from the land of Java 27 years ago, it has to be a capital I interface.
Okay. I will accept that.
Wire interfaces, types all uppercase, but fine. It's like Emacs versus BI. Just don't go there.
We just camel case all of our types. So
Yeah, fine.
int, Boolean, string, whatever. Everything's camel cased. And then values are very rarely all uppercase if they're hey, I'm a constant, but even that's very rare. And then other than that, they're initial lowercase Unix camel.
Yeah, right. I'm mostly there in the same case, same reasons. So I would say this is not in this format.
Okay. If you match on the top with an interface, can you detect in the case statement that you're comparing you're trying to cast it to test for unrelated type? If it's an interface and a hierarchy, and that hierarchy is implemented by 2-3 classes, can you detect that you try to test it for a string, which is not what you want to do in an interface with a hierarchy? You want to test only for the classes you implemented. So I will give you a favorite example with the animal, cat and dog. And you introduce the variable up top in the switch statement. It's an animal, and in the case statements you test it for a string, for example, and you shouldn't. Can you report this?
Yeah. So if string is never an animal, then so I don't think we raise an error for that today, because at compile time you don't have visibility to the entire types that'll exist at runtime. So we wouldn't report it as an error, but yeah, we could certainly detect that there's no strings that we know of that are animals. Yeah.
And report it. That would be good.
So you should be able to report it when you close over the type system.
Yes, we could, but again,
it doesn't need to. It doesn't need to close. You can just test for the type you seen implement this interface.
That's not what I'm saying. I'm saying you catch the bug early. It's probably a bug to accidentally make a switch that you always take the default. That it seems like, you provably only hit the default. That seems like a bug. So I would be willing and interested in getting the report at some point, rather than just constantly hitting the default case.
That has to inspect the values as much as it can. That we discussed that with
when he closes the type system, there's a point where he says, I now know that strings are never animals.
Right.
Yeah.
So my guess is that, when we get around to that level of optimization, we just eliminate that case label.
Well, that's performance hack. I'm wondering if it makes sense to report, hey guy, this code has the following, but it's like I get these out of IntelliJ all the time. This toast is always false, always true, something. There's some report there.
Right. But again, that's not happening until link time, so it's a lot less. Unfortunately, it's a lot less handy.
Yeah, you're right. Fine.
You wouldn't get too much from the exhaustivity, because it's not closed type system. You can have stuff that you don't know about it yet.
Yeah, so we close over the type system at link time.
Yeah. And at that point, maybe it's too late to complain. Yeah, fine.
Okay, cool, Cameron, cool.
Yeah.
So, do we have another topic?
Oh, I can do the 30-second AA update before I take off for Jay Crete here. Looking at overloads at Henley Milner, and I think I have them sorted out. I have reasonable, interesting test cases that are doing the right things for overloads. And the Henley Milner side, I need to do a little bit more work on the AA side, and I'll finish with ad hoc overload, polymorphic overloads with type reference.
Where do you seek to resolve the overloaded methods? How do you detect
The Hindley-Milner side gets a list of functions in the overload, basically. And he applies them to, he does a trial unification with whatever he's got on the other side. And if exactly one successfully trial unifies, he makes it legit instead of a trial. If more than one successfully trial unifies, you're still ambiguous, and he waits and sees if you get more structure, it forces it just to breed one. But if you only ever have two or more, then he claims you're ambiguous. And if you have zero, then it's just the same as you had a function that you applied the incorrect arguments to, you get a standard unification error. Yeah, none of these work. So, you don't want to complain about it as a standard thing. So I can throw down like stupid test cases. This is from my core AA syntax. So I added a new syntax in the universe. So if I wanted to say, hey, multiply as an operator is actually going to be overloaded. So here's the overload syntax. So this is the overload syntax. And in the core language, so AA proper has a cleaner syntax. So I would say I have a function that takes an int and an int and returns me maybe a primitive int multiply. I say int and int. Let me try again here. X and Y, X and Y. And I'm gonna make this more obvious in a second here. I have a second one of these where this one does an F multiply and this one does an I to F on let's get this correctly, I to F on X. Ready? Okay, so if Y is a float and I can pick between these two. So let me come back here and say, somewhere in the world I have an int wrapper, which is a function which, given some primitive int, makes a field, which I'm going to call the primitive int field. This is the primitive int. And now I have these guys actually don't have an X because that's implicitly the II, the primitive field. And so they'll do like, II here. I have to convert this. And Y pulls out a FF if you're a float or a .ii. So here is the miss the correct things. Yeah, okay, so here's a primitive that was a funny thing. Let me space, let me go to Roboto. All right, here.
So that defines an overload for an integers and a floats.
Yeah, so this is an integer wrapper, is a thing that behaves like an integer, except it has the multiply, and if it's second argument, so I would say, oh, make an integer wrapper here of 17, which I can then say, oh, multiply this, oops, multiply that, gosh, hello, times whatever I got, I wrap of 13, and you get 17 times 13. So maybe I did an F wrap here. And I need my Roboto back of 13.1, and then you get a float back. And in this case, the wrapper syntax is there to, it brings me back around to having, and I'm trying to Roboto uniformly here, what the hell? It brings me back to having the primitives that you write are not primitives, they're actually structs that have like fields like multiply in them and add, subtract, all your operators are on them. And then they do standard type inferencing for deciding when to widen. So this is a widening operation, classic widening operation for C code done with overloading. That's probably pretty close to the right answer here in terms of syntax. So this is internal core AA for my type theoretic language, which only does things with like Lambda Calculus. The only new syntax I added was the overload syntax there. That's the only new syntax.
This at the bottom is the intended syntax, does it?
I'm sorry?
This is the intended syntax at the bottom.
Oh, that's sorry, you're right. That's the intended syntax for doing you actually have to do this in the theory language in the core. Because this is a field lookup of a 17 and a multiply. It gets you back a function
Hmm.
The semantic way to think about it is it gives you back a function which multiplies by 17, which
Yeah.
you then bring in either 13.1 or an integer, whatever you're going to do.
So not this one.
Yeah, 17 of 13.1. Right. Now, what's really going on, obviously, is that I have a struct type, which when I throw the 17 in the IWrap, I get a structure back. Oh, that's what I'm missing. Ah, yes. So confusion error. Here's my confusion. I stopped short. Go away, Google, on @sign.
Hmm.
Okay. When I call IWrap, I get a struct back. So this is nothing that you would write as a person in main AA. Core AA is a language theoretic hack. This is the entire breakdown, blow by blow by blow.
Mhm.
So handing a 17 gives you a struct back, which has the primitive wedded, buried inside of it. So you get a primitive int here. And this is just standard Lambda Calculus, by the way. So these are all final fields, actually. And I have this overload syntax, which says there's an operator. I just call it in core A. In main AA, it's the underscore, multiply underscore. In core, it doesn't matter. He doesn't do any operator syntax. So just as a field lookup. So
What does the asterisk mean?
that's multiply. Would you like me to say multiply instead here?
No, I was just thinking the one after the I and the F looks like a different syntax than the underscore, asterisk, underscore.
Wait, I'm
That's
sorry.
setting the associativity, the underscores.
Yeah,
Is that
the
correct?
one that says colon float, that's the main AA language showing an infix operator.
Yeah, infix.
And the Lambda Calculus version doesn't do operators and doesn't do infix. He only does standard Lispy applies. And you pick your operator precedence by the order in which you do Lispy applies.
Hmm.
So this is standard operator precedence syntax. Yes, operator precedence is so infix operator precedence syntax, and this is for pure Lambda Calculus AA.
So you're going to get into all those games of like, is star more bindy than plus?
In main AA, I have operator precedence just the way you expect operator precedence to work. Is that what
Mhm.
you're
That would
questioning
be
here?
translated by the parser to.
Yeah, my question was, is all operator precedence a core AA question, or is someone who's defining overload get the ability to specify their own operator precedence that may potentially be confusing?
Core AA doesn't have any operators and nor any operator precedence. Main AA does.
Ah, okay, got it.
So, okay, so you've defined this overload syntax, but what does it actually mean? Does it mean that it like runs them in parallel and it just magically picks a function, or is it like type?
Yeah, well, okay. Yeah, that's the right question here. I'm sorting out my where's the I'm finishing up my float version. Maybe I got this parentheses right. Okay, so what it does, so this is the Lambda Calculus semantics here. It says, I have two functions. I'm going to pick them. I want to pick only one of the two. At the time I do unification, I typically unify an overloaded term on the left with a function term on the right. Or unification, so swap, whatever you do. If I'm unifying an overload term and a function term, then I take the function term and I unify it in turn to each of the functions inside the overload, doing a trial unification only. So none of the results stick. I then ask the question, did this trial give me an error? If it gave me an error on all terms except one, then I say you're not ambiguous anymore. Keep the unification, no longer a trial, just unify and be done, walk away. And that's your answer. If I still have more than one error, then if I still have more than one unification without error, then it's not yet unified and I stall, basically, revisit when the one or more of the parts picked up more structure. So the usual thing you start out with is I have an overload term, which I know has functions internally, but the other guy comes up with a leaf. It's just a standard Hindley-Milner leaf variable. It's no function yet. And I try to unify a leaf, and of course it all unifies. So I say, okay, everybody unified, you're ambiguous, I wait. Later on, that leaf unifies to some function with some of the arguments. And I try again. And then I say, hey, do you unify now or not? And I suddenly, maybe I get still multiple unifications work. And then I say, still ambiguous, and I wait. And then, you know, the arguments go from being whatever to being, I'm a structure argument that has an int field versus I'm a structure argument with a float field. And then I try my unification again. And he says, you know, this one works, that one failed. I have exactly one success. Now make that unification stick for the whole overload. The entire overload now unifies to exactly the one unification that worked.
Here, by waiting, you mean the resolution is delayed and...
Yeah, so in the standard Hindley-Milner algorithms, the algorithm W, algorithm J, you walk in order.
Yeah.
Right? In my version of the universe, I can do things in any order and I can revisit, and it's all monotonic. But it gives you the same answer for the same reason. Like if I don't have anything special going on and I walk in the same tree order, I get the same answer without having any complications having a fucking work list.
Yeah.
Okay, so since I have the work list, I can do a bunch of other stuff, which also shows up and doesn't do in tree order, and that has to do with combining, you know, Hindley-Milner and flow typing. But it also means in case of overloads here, I can just delay and it sort of falls out of the algorithm for free.
So if go ahead.
If I have a, go ahead, Alan.
No, I was just going to say, I mean, they look to me like they're type classes. They just have a weird syntax. And they only
yeah, so I stared at the type classes for a while, and they're not type classes because I don't have to name the type class ahead of time.
Right. They're single method type anonymous type classes, if that makes sense.
Oh, interesting. Okay.
Well, I wouldn't classify
the type inference algorithm, like what we described for type inference. That's it. That's exactly how type classes work, because they wait until they can solve the variables, and then they solve the variables. And take them.
That's correct.
Okay, when I stared at the type class paper, it's even up in my browser, even right now. He very clearly says, and I had to name you a type class. I didn't infer your type class. And so I said, I don't want to go there. I want to know what I can do for inferencing without having to name me a type class. So I don't come along and say, I'm the type class that has a multiply whose second argument is either an int or a float. That doesn't show up anywhere in here. There's no names for type classes floating around.
So,
and now you can tell me that that's the same as a type class that I got some limit, and maybe it is. I certainly stared at the type class paper just, you know, like I said, just earlier this week.
Well, like, okay, I mean, so like there's a second paper called like a second look at overloading, and it's by
yeah, throw the link out, because I got a bunch of papers that I've been staring at for overloads. This is the one for the Tufts University class notes.
Have you looked at closures multi-methods at all?
I'm sorry?
Yeah.
Have you looked at closures multi-methods at all? Because the syntax looks a little reminiscent of that.
Oh, I grabbed the syntax from, which possibly Clojure did as well, from a 1992 paper by Giuseppe Castanaga, who did a particular syntax for how to do overloads. I'm trying to throw these things into the docs. Let me find the links. Links.
So in Clojure, if it can't figure out all the types, it just inserts a runtime dynamic check and dispatch code. I assume that you don't want to do that without some kind of permission from the developer.
Yeah, right. So if you do a thing that looks like a virtual call like setup, I'll do a virtual call like behavior. That's a runtime test that you get by doing a vcall like thing. This is an ad hoc polymorphic overload, which I can tell at typing time that it's unambiguous.
So how would the code look different if I was okay with you just doing a vcall?
No, I didn't.
Oh, so the vcalls require you to have a sort of a standard hierarchy, a subclassing like relationship. You took your field, you took your base object, you grabbed the field in question out of it, So this is an overload. This is a V call. It's going to look just like it does in any other language. I come up with some object O here. I don't care. Obj equals however I got there, and then I'm going to say obj dot field, and then it's a function. So now I put arg. That's a V call. But you know,
I mean, that makes sense to me.
Okay, replace word obj with this, maybe, or self. Some people like self instead. And this is toString. Oops. For instance, but toString is just a field. I pulled it up and then I executed it. That's your V call.
And when I call toString of this, can I have that toString function overloaded on a number of primitives and then have some default case that says call this.toString if I failed to find something?
This version is single inheritance only. Literally, now if toString pulls up an ad hoc polymorphic overload, then I'll do overload resolution.
So I think if I heard you correctly, what you're saying is this approach is the same as what C++ would compile to under the hood.
For ad hoc polymorphism, or
no, for a V call on a.
Yes, this is what both Java and C do for a V call. C++ and Java do for a V call, and it optimizes the same way and has all the sort of same semantics. Like that's a paradigm that's been in use for a very long time, highly successfully. So I'm just going to take it as is.
Yep.
The ad hoc polymorphism is me trying to do type inference on polymorphic overload types without having to, well, do type inference without having to have people give me names. And the papers I saw said you had to say, I do hashable, or I do equalable, and therefore I support the following functions. And therefore I can tell that I have an equals call or not, or something. You know, if I have a hash table, the key has to be hashable, which means it has a .eq and it has a .hash or whatever, right? But I named it, it's hashable. Well, maybe I want for clarity of exposition, but do I demand that you must write hashable or else you can't be used in a hash table? No, I want to infer that you can be used in a hash table. If you didn't bother to say hashable, I'll infer it and it's fine. So I don't want to have a type class name specifically given. So I was looking for how do I infer, and what I came up with, probably since I just read the paper, is extremely similar to what the type classes do. Yeah, you're busy writing. I know you do the, well, fine. I use colon for the syntax for adding a type. Yes, you're making the functions for toString with all the different overloads, where the args are given a bunch of types, I64, U64, and the like. Yeah. And did you intend a lowercase or you're uppercasing? So this toString starts by virtualing off of the this pointer. Then your last item there said, oh, virtual off of the arg. So I have a combination I'm doing here, some sort of toString with the this plus also whatever the arg happens to be. Yeah. So generally speaking, and then single arrow for the function body. Yeah, not the double arrow. Yeah. So for me, if you've written a type and I claim that's unambiguous, I can figure out that's unambiguous, I'm all happy. Here I'm going to blow up on I64 versus U64 because I'm not distinguishing them. And that only shows up when you assign
at runtime. It should know if it's an I64 or U64 though, right?
No, they are bit pattern equivalent and they are semantically equivalent unless you sign extend to a 128-bit thing. So I haven't sorted on 128 bits or not versus things. If you do a U8 or a U8 versus an I8, that sign extension has different semantics.
Yeah, I deliberately wanted something that had some but not total overlap.
Yeah, I got it. So I'm all happy for the float version because he will be different. The U and the I, I'm going to right now claim, not, oops, no colon there. I'm going to claim, no, that's ambiguous in that sense. So I'll blow up on you when you build that overload. So this is the main AA syntax for building an overload. You just keep assigning functions onto the variable in question, who accumulates functions whose signatures can be proven to be unambiguously disjoint.
It seems like you have a problem if you have something that's actually ambiguous. That 3, you don't know which of these 3
Well, I
things it
claim
is.
error here.
But if I do tell you it's an I64, like,
No, error here. Because I64 and U64 are not currently separate types in the universe. Now we could argue I8 versus U8, and then I have to go sort myself out some more and make sure I believe I have a clean answer.
sure.
Yeah.
I think the
And
same
then-
question still holds.
Yes, same question. Yes. So now I have a problem that I don't think Henley Milner can distinguish those because I don't have that set up that way. So I think right now I'll claim they're ambiguous and blow you up right there. Not at the call site, but at the def site. Because you'll build a set of functions. And then I'll have to go stare at it, think if there's something else I can do.
What about
So the error that I would get is what? At this site, you attempted to reassign
Redefine,
to
yeah,
string of int?
You're adding an ambiguous overload. That's my current theory.
And does the syntax at the top solve the problem for my syntax at the bottom?
Could in fact be that I blow you up here at the call site, which means I let the ambiguous overload live as long as it's never used. It's actually probably really happens is it probably blows up at the 3 for being ambiguous there. This requires Henry Milner to distinguish I8 from U8. And right now, my Henry Milner loses precision on integers sort of on purpose. So at the moment, I will also claim that's an error.
The way that can go around it is a wrapper class to
Well, that's
introduce
the
it.
wrapper class I have for IWrap and FWrap. I'm assuming you're already talking about the wrapper classes
Mhm.
where the primitive int is known to be an int 8 versus a uint 8.
Hmm.
And I'm likely to complain that that's not an interesting distinction. I'm going to blow up on you on it.
Mhm.
I've done a lot of I8.
But if I have a runtime test, I no longer have the ambiguity, right?
Well, you can't runtime tell I8 from U8 apart.
Oh, because there is no concept at runtime. They just
They're
are the same
primitives.
type.
They are primitives.
The
Yeah.
goal of the wrappers there is that I can implement them at 0 overhead, literally 0 overhead at runtime. So those wrappers look big and complicated, but they have a 0 overhead representation, right? It's just the one where I know everywhere it's a wrapped I or a wrapped float, and that I can tell them apart that way. So there's no runtime test here. I want to not have the runtime test.
They're type safe macros.
Yes, that's a good way to look at it.
You're welcome.
I'm not wanting to use the word macro, but roughly speaking.
I didn't mean it as an insult. Sorry.
Yeah, no, well, fine. Roughly the same thing. So
that's the type safe part of it, is that
When
you can see all of the. It's like when you pull on a string and the knots come out, right? It's like you can see all the knots come out. You're like, okay, I'll take that one. Knots came out, I'll take that one. And it all comes from the same piece of string, but they end up connecting, because they're expanded is really the wrong word. They're not actually expanded. They're kind of nailed down based on how and where they're used. right?
Yeah.
Hmm.
I missed your analogy, but I got the type safe macros as being a reasonable.
When
reasonable
Cameron says macros,
concept.
it means strictly more powerful.
Okay. The other thing is that
Usually when I hear macro, I just think it doesn't evaluate its arguments before it executes,
Well,
which may not be
Yeah.
fair.
Here, right. So here the claim is I know exactly precisely the types of IRAPs and FRAPs everywhere, and therefore I don't need the overhead of a virtual header to tell them apart at runtime.
Right.
so this thing what will turn by the parser, or how it will
Yeah.
turn to.
Yeah, the parser does that.
It will
So he
desugar
says
this.
17. Oh, I parsed to 17. Let me go to the make me a number piece of the parse code, who turns around and says, I call, oh, you're an int. I call type int, make me a wrapped int. Or I guess I call type struct, make me a wrapped int. And it makes a structure back with the int wrapped. And the structure, to, you know, be efficient and well and safe, says you're a class of IRAP. And you have, since you're a class-like thing, you have a class header, which has all the multiply, add, subtract, multiply, divide fields, not here. And the actual implementation of a wrapped int from the parser's point of view is, you know, it's a Java V call, it's a primitive 17 type, and it's, I'm a class thing, and here's my class structure. So it's actually a pretty damn small little thing. But then when I go say 17 times 13.1, he says, oh, I found a multiply in the infix position. I look at my operator table and it claims that multiply exists as an operator in the infix position. Okay, let me parse out the next guy. All right, fine. Now type safety checks or type checks says, take 17, which is a wrapped, you know, it's a wrapped integer. Look up the field underscore multiply underscore, because that's the operator syntax. And I find, oh, an overload. Okay, I got a couple functions I might choose here. Do any of them work when you're past this 13.1, which is an FRAP? Well, it turns out that only one of them works with an FRAP and the other one doesn't apply. So I get a single result back. And then I didn't actually finish out this job here. This is IRAP of that result. And all of these guys have to do the same rep. So this is the semantics. The implementation obviously boils down to, you know, just standard integer or floating point multiply or whatever. So that's the final piece of it. I said final before. I know.
So they're implemented as classes, if you will, with functionality.
Yeah.
But at runtime, that's the same pattern as in Scala extension classes. That's or opaque types in Scala 3. You can implement the exact same thing. You declare it, and when you figure it out, you make a version that doesn't introduce any classes, just on the primitives. It works on the primitives.
Right. So my goal here is to have the semantics be explicit, and I can test that my semantic theory is correct. But the implementation in the main AA will carry the semantic types around, but when you come to go emit machine code, you're going to get 17 times 13.1. You're not going to get any class structures here or anything like that.
That has to be guaranteed by.
And that's a hard guarantee for performance in the language,
Okay.
But I absolutely needed the semantics to believe I could do the overloads. I could do overload resolution without having to be slimy about things or whatever. I looked at these other folks doing, you know, exactly small integer widening from C land with strong types in Haskell, and then I don't know, maybe I looked at a couple other languages, and the answer was they always did a dork ass thing that no one else uses for any other purpose except to handle automatic widening of ints and floats, or you were like Haskell and you had to widen manually. And I'm Haskell, like, oh, come on, surely this can be done.
Yeah, they elegantly sidestep by declaring type class a number, and which number it will get figured later.
Right. And for me, at least I'll know which number, and I can tell you at error report, I can tell you what all these types exactly are, because they have to resolve or there's an error. right? So I can at least give you a decent reporting if you ended up using you're passing a float off to an int only function call or whatever the hell.
Yeah, we took a much different approach with this, that the 3 is not an int. And
What it is?
13.1 is not a float.
Okay, what it is? They're literals or?
Yep, exactly. 3 is an int literal.
No.
So
okay.
at what point it's converted to the 17 to an int and 3.1 to a float?
What
as
do you do if I
early
just
as-
read a thing in from the command line? What's the deserializer do when he parses a bunch of ASCII text and wants to make some integer and some float?
Well, int literal knows how to make both ints and floats. So you just say new int literal with a string and 2 float, and you're done.
So you classify it. So
I,
do you have the literal as a hierarchy? You have a literal on top. You have an int literal, or float literal, or some other literal, or it's a just literal. You can turn it into an int or a float or whatever you like.
There are 2 numeric literals. One is called int literal, and the other is called FP literal.
Yeah, but you see, at source level, you still distinguish it. Is it a literal, int literal, or is it a float literal? As I understand.
I'm confused. Like if I just do, I'm fucking writing matrix multiply, do all my internal variables to be called float literals. It's all float values that are all non-constant by any reasonable metric.
Right, but if you put them in a matrix is has a compile time type of, matrix of FP32 or whatever. So the compiler does the work at compile time of turning those int and float literals into FP32s because it knows it has the same rules at compile time as
you have an FP32 type. This is my FP32 type.
Yeah, if it's
not, I'm only using constants to make life easy to wrap your head around, but this is my standard FP32 int32 type.
Actually,
and what I'm saying is for us at compile time, the 3 is not an int or an FP.
It's not an int to do. It's an int literal.
It's a separate thing called a literal, and we get rid of that as soon as we can, right?
Yeah.
So the compiler
I don't
knows
have a separate literal notion for things that are known to be constant at compile.
I've never seen it done before, but
in Scala 3, and in Scala, I believe it's exactly the same way. If you write 3, it will tell you int literal, which is a type of constant, I believe. Yeah, something like that.
So I equals 3 would be basically 3 being an int literal. It's as if it says 3 to 64. Right? But that's done at compile time, not at runtime.
By the lexer is recognized it as an int literal, not any type.
The lexer lexes it as a literal token, and I think there is actually an int literal token. Yep.
Yeah.
Yeah. I don't actually have a lexer. I'll just take the 3.
And the reason that we developed,
away with it.
again, I've seen it done different ways. I've not personally seen it done this way, but it sounds like Scala does it the same way. The reason we did it this way is because it's such a pain in certain languages where they assume that 3 is an int 64. So you say, byte B equals 3, and the compiler says, no, you can't do that. You can't put a 64-bit value into a byte.
Right.
And it's like, okay, I'm not going to name any languages, but I've lost a lot of hair.
Yeah.
No, for me, 3 is it's an integer value. It's a type as a type 3, and of course, the type 3 can be thrown into a byte typed just fine.
So another question: can the int literal 3 appear in a type position, Cameron?
I can. My 3s can appear in the type.
I know you can. I know you can. Can you?
So no, we do not, and this is what we talked about a couple weeks ago. We don't have a dependent type system for.
But
it's not dependent type.
It's still not. Yeah, it still doesn't count dependent types.
Well,
it's a literal type.
Yes, it's not dependent types. It's very different. No, that dependent word has some heavy duty overload.
Well, in Scala, sorry. So let's say in Scala, it's type X is 3 and it's 3. That's not that's a literal type.
Yeah, yeah, and I have very similar syntax in AA.
Yeah, we don't have anything like that.
Okay.
So yeah, well, the minute you allow it to appear in a type position, the compiler can do stuff with it. It's so let's say if it's a type math, that would fail at compile time if you have the type literal.
I'll blow you up on that too.
Yeah, you can have the interesting point here would become the string literals, because the classes of the names, the variables of the class of the names can count as string literals, and that's you are entering a more powerful strictly concept.
Yeah, I can do that too.
And you can. This is just an idea, of course. You can work with it. We can. The practicality are certainly there, but they're not hugely applicable to a wide range of problems.
Yeah.
At least my opinion.
The one case that I wish we had it was for ints. I don't actually have a sense of how it would be useful for anything else.
Let's say a conversion. Let's say
I'll throw. Okay, that's you typing. I'm gonna go do my own down here. Gonna let me do it. All right, Google. Thank you. There we go.
So, in type quantifiers would be such a useful thing to convert between units at the type level to ensure that a literal is some type that has to be converted to other types.
Yeah, so color is an enum of some sort?
Yeah, and right, and red is one of the enum picks, of which you have to pick that enum, not.
Yep. So we do have that for enums, but unless int is an enum, we can't do that. So yeah.
Okay, fine. Yeah, I don't claim it's useful, but I could certainly say color is typed to be a 3, and you could only pass a 3 in, and it would be type error to pass in anything other than a 3.
Right.
But yeah.
No, I'd love to be able to have the same kind of enum behavior specifically on integers. But I have not been able to, find my grand unification theory for that yet.
All right. Yeah, that's my lattice game going on, but I don't claim it's required. That's not necessarily.
Someone's beautifying the code.
Yeah. I was watching it in action here. I took some extra blanks out so it didn't.
I believe it's Aaron. But if Aaron pastes it in the code, yeah.
It's a VS Code's Java lang highlighter.
Yeah, what needs to happen for Google Docs is give me a freaking make this code and highlight it with your best guess as a highlighter. Yeah,
it's not a high priority. There's no programmers there.
Hey, Google. You would think.
Well, as the coffee compiler progresses, we'll have to move to a more sophisticated thing. If I don't have.
There's a whiteboard in Zoom. Maybe they got color coded.
I'm more
honestly, I think this has been working surprisingly well.
No, it has. I'm totally I'm joshing around. It's totally good here. Although your coloration of the second FF on the FRAP guy, one of them got color coded and one did not.
Yeah, it's an AI.
Yeah, thanks.
So, okay, guys. Do we have some new topic, or we can?
Yeah, so I was curious about what people thought of execution order. The other day, Cliff asked something that was like, do you do top-down execution for the cyclic imports? And it's like, oh, well, you hit this import, and then you hit this import, and then you go over there, and you just by top-down executing, and then following imports and top-down executing, and following imports and top-down executing, you get a kind of nice order of execution.
But on the
A
downside, you
well-
can wait.
A well-defined.
A
order.
well-defined order of
Well-defined.
execution.
Yes,
Yes,
that is
changing
the-
the order of your imports could change the behavior of your program, which
Yes,
is an interesting property.
yes.
And I was curious what people thought of that and what people thought of main. So like you could imagine an AA program where if I just take the AA tool and say AA space name of file, it goes through and top down executes everything and then stops and says, look, I have built the binary that is the state after I've top down executed everything. So you get built time execution. And then when I say to run the thing that comes out of it, then I call main. And anything you want to run during compile time, you just don't put in main. And if it's dead under the assumption that main didn't get run, then it doesn't have to be compiled during the compile time part.
That would be correct
That's
for
not-
the executable, but for the library, you do want all the functions to be.
Yeah, but that's not the semantics that I was headed for.
Right. So like Rust has build RS. And the first thing it does when you do a build is it builds build RS and finds all the dependencies of build RS and builds all of those things. And then once it's done building everything that's necessary to execute build RS, it then executes that script, which will often do things like turn a bunch of protobufs into actual code that you can run or whatever compile time thing needs to happen for your arbitrary project. And then when it's done with that, now it runs the actual build of everything because it's generated whatever code needs to be generated.
Actually, I believe
And I was
that's
thinking it might be a reasonable semantic to say, hey, if you just call the thing and pass it in, it just runs top down. That's a good way to write scripts. If you're actually saying build, then it runs everything top down. And when it finishes, gives you an artifact that is kind of the state at that point that is ready for you to call it. And if you call it, it calls main.
Yeah. Well, it hands you an artifact that's got a thunk as its entry point that you have to call. Yeah.
So it's sort of
Yeah.
like, does
Yeah.
this solve, can this make a lot of the build tooling go away?
Yeah. Oh, that's interesting. That's a different question. Certainly in a galaxy far, far away a long time ago when I was doing Forth-like things for PostScript clones and what the hell. Yeah, we had behaviors like that. You ran code till you hit some point where you stopped and said, puke the universe out as a WAD that I can call later time. Then we burn that on the chip. And then at the boot time, the OS came up, and after he did his initial boot, he turned around, he called the top level entry point. Now you're running a PostScript interpreter, including
So, like-
all the hash tables of all the font names and all that shit was all pre-baked and cooked up and ready to go.
Right. Clojure is a tiny universe. There's a very small amount of core Clojure language.
Yeah.
But I want to have things like or. Or is a useful function to have without having to import or.
Yeah.
So what they do is there's a prescript that runs before it calls your main code and basically builds the entire world, which is nice because most of the world in Clojure is written in Clojure. It's
Isn't
not
there
nice
some-
because you now have a 2-second startup time because it's
Isn't
building the
there some
entire world.
Isn't there some
I would kind of
statement
like to
that
build the
someone
world
made
at build
once,
time, but I would kind of also like to have
Yeah,
my
right.
language mostly written in my language.
Yeah, no,
Didn't
this is-
someone
this-
once didn't someone once claim that every language sooner or later embeds a Lisp inside it or something like that?
Yeah, that's claim that's been around too. Yes.
I think it was a buggy, poorly implemented Lisp, but yeah.
So I mean, never mind Emacs and it's all Lispy. Yeah, the obvious thing here for me is that I have a version or a semantic or notion that wants to say, this is a separately compilable standalone module. I want you to assume it will be called in the future. All entry points will be called. Therefore, they're all live. Now, cook it down as much as you want, boil types down all you want, optimize, blah, blah, blah. Give me an artifact. So all the entry points are up and available. And that's the
But-
artifact I'm writing up. That's go make me a library.
I believe that's the only thing you do because you don't have main. You do not know what will be called. You have to compile everything into.
No, so I don't have main doesn't mean I'm not getting calls. So the current semantics for AA, and we can argue that, I don't have a module or I do or whatever, is that I'm going to start executing from the start like Python does. The imports in Python are fucking executable. And
Yeah.
he executes them in order. They start importing namespaces into the search path for all other variables. That's the sort of Python semantic. Now, at some point, I want to stop and say, having executed all this code, including building up the namespace and then constructing all my methods and blah, blah, blah. In the end, I'm going to stop execution and just write myself out as a module to disk that later can be brought up with, as an artifact brought up with a bunch of types that I can go type check against, and entry points I can go call if I match the types and yada, yada. So there's a version of the world that says, I'm going to start by executing the things at the start, as unlike Java, which says I do a package and an import. This just populates namespace. There's no execution, right? So instead, I'm going to say I'm executing. I haven't settled. And Aaron and I have gone back and forth on this a few times. I'm kind of like the notion of doing the Python-like thing, and you can execute whatever you want. You can pre-cook everything you want to pre-cook at normal, because there's normal execution. Then at some point you can stop and say, take what I have, compress it into a block box, declare it a module, barf it out, and now I can load it up later and run it.
So this becomes basically your runtime, as I understand.
I'm going to cook in the runtime or whatever I want to cook into that. Yeah. So the module might have like garbage collection requirements.
Yeah.
And I might have to suck in a garbage collector to go with it. And
So,
when I'm firing up some other new thing, if I don't otherwise say something, I probably get a JIT when I fire that guy up, because I'm going to read his code, I'm going to type check it, and then I'm going to execute it, and that's going to ask the JIT to get involved, unless I somehow made an artifact that says, don't ever JIT, but if I get a eval, class for name, whatever, I'm interpreting.
So Aaron, what's the exact the specific approach difference between the Python approach, executing all, or preparing something that would be executed later? That's
usually it's startup speed that I think is the win there.
Yeah.
Although some of it is pure difference of environment. Sometimes there is data that I want to exist in the system where I'm doing the builds, and I don't want that to exist, or at least I don't want that to have to exist in the production environment. So there are times when I want to say, go pull all this schema data. I'm pulling data out of databases during the build. I'm, grabbing the whole world. I've got some distributed hash table. Go give me the 10 nodes that have been alive longest, like really arbitrary things during the build. But then once that's baked, I want it to be stick this executable on the file system and call it. Like I really like Go's deploy model, which is I have a Docker container that contains within it one file, and I execute the executable, and that's it. I have the Linux kernel and my executable. That's my deployment story, and that's kind of beautiful. It's really hard to do that with Python.
Agree.
Really? You can't just have a pile of Python or PYC bytes and just say Python this thing and away you go?
You can. The standard way that deploy is done is you have the kernel and you drop into the file system the Python executable and a zip file, because Python, if you say Python space and then hand it a zip file, it will treat that as a folder, go look for a thing called main inside it, call that thing that's main, and you put your entire standard library and everything into that one zip file.
Right. And how is that actually any different than a Go executable? It's got all those baked into the exe as opposed to baked into the zip.
Time.
That you're not dealing with my pipeline just threw executable number 3, I've got Python 2.7's interpreter and I've got my own library. And
well, that's baking together the Python executable with the zip library better be, well coordinated, because usually you have two, you have a chance to get them mismatched.
Yes, one is better than 2.
I'm sorry.
2 is better than 100, but 1 is better than 2.
I just think you're silly complaining about this, Aaron, because I dealt with React this week and it makes Python look like a walk in the frickin' park.
What?
So
You said JavaScript, sir. Oh, version incompatibility. What? JavaScript? Huh?
That's true. Deploying Python is easier than deploying Node.
There's your 3,000 different version incompatible things that have to all work together. Oh, and you wanted to download most of them dynamically.
I only asked for.
Did you get?
I only asked for 3 things. Yes, it downloaded 3,000, but I only asked for 3.
Yes. And
So
buried
they-
within the 1700th download was a version mismatch downloaded on the 2000th download that came along later, and you blew up with the mystery, none is not a function. And like, what the hell?
The JavaScript guys take this modularity way too seriously.
Well, they have it so fucked up. So they have to be serious, or they are just you get mystery death.
Well,
Oh my God.
the
I
good
totally
news
did
is-
React for a while. Wow.
the good news is if you always stay at the tip, things mostly work. The bad news is if you stay at the tip, every time you do anything, you get a message that says, you have 6 serious security,
Yes.
CRS 10 rated things. And it's like, what?
Yeah, that too. But if you stay at the tip, you also get a random collection of bugs that roll continuously as to what the bug is.
Yes.
And
But if
you
roll
don't
stay at the-
backwards in
But if you don't
time,
stay at the
it-
tip, nothing works.
When I
Yeah.
first got to Google, my tech lead said there's 2 ways to build software. There's pylons and there's surfing. And a pylon gets driven very deeply into the ground and cannot
never
be
moves.
moved again and will never be moved again and is stable because it's deeply embedded in the rock. And the second thing is surfing, where you're just on the waves and you have to keep moving to balance. And if you ever stand still for a second, you're going to
dead.
wipe out.
You're going to
And you have to decide for any piece of software you're building, are you building this pylon style or surfing style? And if you're surfing, you can never stop updating it because it will die.
Yep.
Quickly.
Yep. Live that one. Not certain I want to go there. Fairly certain I don't like going there. It'd be nice if at some point it could have stopped surfing, but I never got to the point where it felt like I could stop and say, and here's the version that will now be stable. Because
I mean, that was always the complaint with Blogger, was they basically stopped adding features to Blogger. They would like to move that entire platform from surfing to pylons so they never have to touch it again and they can just leave it as a static thing for the rest of time. But it's built on Google's infrastructure, which keeps moving and changing and adapting. So it's still a full-time job to keep updating products that haven't changed in years.
yeah, yeah.
Hmm.
Yeah, my experience with trying to freeze React plus MobX plus the 3000 pylons, but I was using another major guy plus all their pylons, was that somebody buried in the guts had, I accept the following versions, and they lied that they didn't really accept it. And so somebody bumped a version and they thought they would accept it, but they did not. And then deep in libraries I've never heard of, called other libraries I never heard of, and I got exceptions throwing. And I never could tell, who hell happened. Or I went back to the surf and all right, the tip works. 2
I
months
will
ago, the
say-
tip did not work. Whatever. Yeah.
One
That's
thing
at
that
least
dramatically increased my respect for the JVM was when I
Yeah,
first
I
saw
hate
a
to say it.
corporate environment try to move from x86 to ARM.
Oh yeah.
And we moved a bunch of Python things over and the C code blew up on us and was like, oh, you need to recompile all these shared objects. And it's like, oh, right, Python defers to C when
Yeah.
things aren't fast enough.
Right.
And we tried to move our node and it blew up because it turns out there were all these node packages we didn't realize had compiled C deep inside them.
Great.
And we thought, oh, JavaScript is so fast in its modern day interpretation. We figured things were actually JavaScript all the way down, but they just as much fell back to C libraries.
Hmm.
And we moved a bunch of our Scala code to ARM, and it just worked. Because it was
That's for
Scala
JVM.
where the things that were performance sensitive were written in Java, but that meant it was all on the JVM, and it just moved to ARM and didn't miss a beat in a way that migrating Node and Python to ARM was hard.
Yeah. Yeah. All right.
Migrating our Node stack to ARM involved finding a Fortran compiler.
I'm tempted to ask why.
No.
The library was called LAPACK and did a bunch of linear algebra stuff.
You said it. Yeah, LAPACK. That'll be it.
And it turned out that the LAPACK was a bunch of Fortran code. So we had to recompile the shared object for LAPACK using
Yeah.
Fortran to get
Yeah.
it to run on the ARM chips.
Yeah.
And it's
Yeah.
like, no, like we do a bunch of AI. Our matrix multiplies are important, man.
Yep.
Fun stuff.
I did a big data startup, I both fought against LePac and I benchmarked against it and all kind of other things. Yeah.
So
All right.
what was your opinion of benchmarking LePac?
Oh, we mostly did better algorithms where it made sense. If you're doing
I guess you're parallelizing things and they don't.
I'm sorry?
You were parallelizing things in a way that they don't.
So yeah, so independently, so separately, there's a bunch of things. There's if we did one-dimensional array things, the Java would be just fine. If we did one-dimensional array things where we actually got to compress shit, we actually could win because it was all bandwidth limited and we would win the bandwidth wars. We were cluster parallel as well as single node parallel. LePac was not. We had more sophisticated algorithms for like generalized linear modeling and the shit like that. So we would get better answers for, as far as LePac went on that kind of thing. As soon as you went two-dimensional or three-dimensional arrays, we did not do tiling. So LePac would win handily there. There were a few algorithms which we didn't care to go parallelize. LePac had good ones on, like Chomsky decomposition for doing GLM involves basically matrix division, which we did up to a point, and then there's a certain scale at which LePac would win, a certain scale we win, depending whether you were where you were on the size of dimensions of things. It was mostly we found we didn't need it, but we fought it. We benchmarked against people who used it, and we would win on precision of results. And we would mostly be the same on speed until a multidimensional array showed up, and then you get crushed. So that was sort of the trick. We didn't need multidimensional arrays for our algorithms, so we would just steer the conversation to saying we're not actually doing multidimensional arrays a la like pandas for solving this problem. Like one-hot encoding is typically done in pandas style with a second array or array of extra dimensions where you have the one bit set on the diagonals, and then you have a giant two-dimensional array, and then the multidimensional array guys like Namet, and we buried that one into the algorithm itself. So we had a custom smart thing that said, oh, this is a one-hot encoded version. We'll just skip all the zeros. We don't have to explode the array out. We don't need the multidimensional array hack for that. So we're back to being, we win for that flavor of things. That kind of shit was going on all the time. Mostly in the sense it was kind of a wash. We could match performance where we cared, and we tried hard not to care on multidimensional arrays.
Sounds like an impressive win for JVM going up against some
I thought
organized, optimized libraries that are.
I thought we did very well on that front. We could routinely newer algorithms. So in the last, since LePac was around, newer algorithms showed up for a lot of these, model generation things, and the newer algorithms beat the older algorithms. Speed independently, whatever. That's a separate thing.
Get faster code, use the better algorithm, and you win. Yeah,
right. And then the other one is if you're a single dimensional array, Java does the same thing as Fortran and C does. That's all the same. It don't matter. So that was, they did a good job with single dimensional arrays. So does Java, and then you're done. Now you do multidimensional arrays, there's a different story, but you don't need them for everything. And then turns out you can, in machine learning land, you typically don't need them. So then it doesn't matter.
So is there something you would want to add to AA's standard library to make multidimensional arrays more tiley by default?
You would want them to not be done the Java style let's back up a little bit. I worked out how to do this in the JVM. It never got implemented. There is a theoretically decent way to do it where you demand that the multidimensional arrays are aligned in memory in order the way that you would expect them to be done, like a C or a Fortran. They're just smashed end to end, and the garbage collector will not move them out of that pattern. You can still have nested arrays refer to each other in a nested fashion, but if you know you have a multi-dimensional array and you're at the start, then all the nested internal arrays are back to back to back plus headers. So when you do your array dimensional math, you add the header part as the scaling that fits, and you can do direct multidimensional. I found the part with just part of this slight variation change on multidimensional array math. Okay. As soon
But
as
it
I
seems
can
like
do
there
that,
weren't
all the-
promises there that Java could have laid out that array differently if it wanted to lay it out in a tiled fashion.
Yeah. So the requirement here is
Right.
that.
But
you-
there is no constructor in Java for a multi-dimensional array. There's a constructor for a single dimensional. That's the problem.
There is there is actually a multi-dimensional array constructor bytecode, a single bytecode which builds multiple dimensions. Fucking had to implement it, had to JIT code for it. I know it's there.
Yeah,
Okay,
I'll take
having
back what I
said
said. then.
that, the language runtime does not guarantee you that the built nested pile of arrays are all co-adjacent. They can be randomly scattered about. And that's the hack you need to do, blocking, tiling. And tiling's unfortunately worth the ratio between L1 and main memory performance speed. So that's, it's a 10x thing, kind of. It's an interesting fast. If you're trying to solve for tomorrow's weather today, instead of tomorrow, 10x is interesting.
It's also something a JIT can do better than a static compiler because it can learn the sizes of the caches and make good choices in the tiling that is really
Typically-
hard for something like LAPACK.
Typically, those guys do exactly that. That is, they have their tiling math has a number, which is how big the tiles are, and they go ask that question. And then at the start of the world, same as the JVM would ask that question. How big is my L1, L2, L3? You ask the question, you get an answer. Now, the algorithm itself can take a variable count that says, when do I recurse and when do I not? And how big do I make my chunks as I recurse? And that's same for Fortran for Java, right? That's not the issue. All right, I want to go because I'm leaving for Crete at an obscure hour in the morning and I have a butt ton of packing to do. So I'm going to call it.
Okay, guys.
And next week I'm off because I'm going to be at J Crete.
Okay.
I'm going to be first conference in 2 years. I'm kind of excited. All right, folks.
Cool.
Stay safe. Have a good trip.
Yes, thank you. I will. And look forward to see you guys in 2 weeks.
And
Say hi to
bye.
everyone. Cheers.
Bye.
Bye.